Let's look at logical operators. In the previous labs, we used basic arithmetic operators like addition and multiplication. These operators take two operands and perform the operation giving a result. In this lab, we talked about relational operators like less than or equal to, which compare two operands and return true if the left value is less than or equal to the right. A logical operator is an operator that works as part of a Boolean expression. A comparison is something that can be evaluated to true or false. Logical operators combine Boolean expressions and return a Boolean result, true or false. Logical operators require two operands, just like arithmetic operators. Let's review if statement syntax. If statements are used in the following manner. Int x equals 2. If x is equal to 2, print hello. But what if you needed to run a code block only if x was greater than 2 and not bigger than 100? You could make two if statements, one inside the other. However, there is a better way. The AND operator, which is made of two ampersands, checks to see if the two conditions are true. So we have int a equals 2 and int b equals 4. If a is equal to 2, which is true, and b is equal to 4, which is true, it prints both are true. The OR operator. This operator checks two conditions to see if either one is true. So int a is equal to 2 and int b is equal to 4. Now if a is equal to 4 or b is equal to 100, it'll print 1 is true. A is equal to 2, but b is not equal to 100. But only one of them has to be true in order for the whole expression to be true. Therefore, it prints 1 true. You can find this symbol for the OR above the Enter key. The symbol is referred to as a pipe. The NOT operator. The negation operator, which is an exclamation point, will invert whatever comes next. Think of it as a not symbol. Let's look at the code. Int a is set equal to 5. If not a less than 2, then print hello. Another way you could read this would be to say, if a is not less than 2, we print hello. A less than 2 is obviously false, but the negation symbol inverts the result, so not false is true. Let's look at some examples. So a is set equal to 4 and b is set equal to 6. Now we're going to test a greater than 1. Well, that's true. But now we have to test if b is greater than 10. This is false. Since one side of the AND is false, the result is false. Let's look at the next one. A greater than 1. That's true. Now we have to test the other side of the OR. B greater than 10. Well, this is false. But since one side is equal to true, then the whole OR expression is equal to true. Let's look at the next one. A is equal to 4. Well, that's true. Not a equal to 4. Well, that's false because a is equal to 4. If we test a not equal to 4, well, that's false. And we can negate that expression as well. So a is not equal to 4, which is true. You can see how this is confusing. Now let's look at the OR and AND. Be careful how you evaluate these because you have to evaluate the AND first. So you really have to evaluate b equals to 4 and a greater than 1. So is b equal to 4? No. Since this side is false, it doesn't matter what the other side of the AND is. This whole AND expression is false. Now we have to evaluate the OR. Is a equal to 4? Well, that's true. Since a is equal to 4, that's enough to satisfy the OR, and the result of the expression is true. Let's look at the next one. Both of these are AND, so we can evaluate this from left to right. A is equal to 4, that's true. B equal to 4, that's not true. So this expression will be false. Let's look at the last one. A is equal to 4, that is true. And b equal to 4, well, that is false. So this AND expression is false. Now we can get to the OR. Or a greater than 1. Since a is greater than 1, that satisfies the OR condition, so it's true. Precedence. Just like arithmetic operators, multiple logical operators can be used in an expression. How the expression is evaluated depends on the precedence of the operators. The not operator has the highest precedence of all, which is typical of unary operators. The and operator, which is the two ampersands, has higher precedence than the or operator, the two pipes. So be careful. It's easy to think that these share precedence like addition and subtraction, but you really need to think of this more like multiplication and addition. They don't mix, they don't share precedence. Let's look at some more examples. First, Boolean A is set equal to true and false or false. We have to evaluate the and first, so true and false results in a false. Now we evaluate the or. Since the left side of the or is false and the right side of the or is false, the complete Boolean expression is false. Now let's look at the next one. With parentheses, we have to evaluate the or first. So false or true results in a true. So now we evaluate the and. Since the left side of the and is true and the right side of the and is true, this prints true. Let's look at the last one. Remember that we have to evaluate the and first. So true and false results in a false. Now we go from left to right. So false or false is false. Since this side of the or is false and this side of the or is false, the whole expression is false. What do you think of this code? Well, this code prints 1. So let's look at why. We have to evaluate this and first because it has parentheses. So is A greater than or equal to 1? This side is true. Is B equal to 6? This side is true. So this and expression is true. Now we can go over here. Is A greater than 10? This is false. Is B equal to 4? That's false. But since there's an or here and one side of the or is true, then this whole if expression is true and we print a 1. Now that you've learned how to use logical operators with your Boolean expressions, you're ready to do some more code. Good luck.